Okay, hello everyone. We'll be doing number patterns today. Now these questions are again from some past paper questions. Remember, there is quadratic sequence, arithmetic sequence, and geometric sequence. And let's see what we have. Now, there are pentagons. Term one, first figure is one dot only. Second one has 5 dots. You see the shape. And third shape has 12 dots. You can even count, and it is 22. Now, the question asked, the first one asked, how many determine the next two pentagon numbers? Obviously, first of any attempt, what would you do is find their difference to see whether it is arithmetic or geometric. And the differences are like increased by 4, and then from 5 to 12 increased by 7, and then from 12 to 10 increased by 10. Now, the first differences are not same, but if you observe the second difference now, it is increased by 3. Now from 7 to 10, it's increased by 3 again. So that how we find the next two terms, like the next difference will be increasing by 3. So that means it is plus 13. And then I'll add 13. And with 13, the next one, I'll add plus 16. You see the differences are increasing. So I'll add 13 and 16. So that's the point. So the next term is 13 more than 22, so that gives me what? 35. And after 35, what is my next term? Plus 16, then it is 51. So those will be the following two terms, 35 and 51. And the nth expression, okay, you know that you just need to say 2a is the second difference, which is 3. That gives me 3 over 2 for a. And then what else we have? We got value of a is 3 over 2. And then 3a plus b was the difference between first two terms, which is in this case, let me highlight it. The second difference is 3, which is my first thing over there. And then the second one I use as 4. Now that's equal to 4 t2 minus t1. And that should give me the value of b. And the last one was a plus b plus c. That's the first term. And in this case, it is 1, so that will give me C. So from the second one, I'll get the value of B, and the last one, I'll get the value of C. And what are those values? Like I can just circle them. So that's the 3 values that we use. All right, so you know that. So that first one is a 2a, that first one. Then 3a plus b is the difference between the first two. And then a plus b plus c is that. As long as you don't make any calculation mistake or whatever, you should be getting the answers correct. Now, like what is the value of the other two, then b and c? Let's see. If a is 3 over 2, that's 9 over 2. 9 times by 3, 4 minus 9 over 2. 9 over 2 is 4.5, so it's negative half, negative 1 over 2. Okay. And then what else? We have their sum. So a plus b already gives me 1. So that means c value is 0. Okay. So that's what we got. But don't forget writing the answer over there. The nth term, which is Tn, let me write down the answer. It is 3 over 2 n squared minus 1 over 2 n, and c is 0. That's 4 minus. Now determine which term in the pentagon number pattern will be equal to. So how we solve such a question? We will equate it into the term value. And it's basically solving quadratic equation. Okay, so it's like Tn is 3,432. So it's just solving quadratic equation. Okay, you can get through this solution problem around it. It's solving quadratic equation. And quadratic formula can be used, obviously, and you can actually write the answers after the equation straight. Now, 2.2 looks like a little bit different question. There is negative root 2, there is m, there is 3 root 2. And it says it's an arithmetic sequence. Okay, so the information given is quite necessary here. If it says geometric sequence, we'll do something else. Or quadratic, we do the second difference. Now it says arithmetic, so it's just the first differences. And first differences when it is arithmetic, let me just write the condition that the differences are same. And it works like how? The second term minus first term will be equal to third term minus second term. So that will be my equation. So from T2, from m minus root 2 is equal to 3 root 2 minus m. So then we will solve for m. And what is T1, T51, sorry, the next question. So I can answer T51, I'll just say is A plus 50D. So D is the difference. And A is, okay, we already know what A is. A is negative root 2. So I just need to find D, the common difference, which can be determined after we find M, okay? All right. Okay, let's solve M on that small space. I can make it a bit larger so we can zoom it. How does this equation give us? What was the terms? Remember, M minus root 2. So I'll just write it there. So from this equation, how can we write? M minus root 2 is equal to 3 root 2 minus M. So that's my equation. So it's basically M plus root 2 is equal to 3 root 2 minus M. So take M to one side. 2M is equal to 2 root 2. Basically, what do you get from here? M is equal to root 2. That's you get the value of M. So after you got the value of M, which is root 2, then it wouldn't be a big problem to find A and D. Like I can just say, I will write down there now. So I have negative root 2, then I have root 2, and I have 3 root 2. So what are the differences? Every time we increase 2 root 2 by 2 root 2. See, we increase 2 root 2. That's my D. So, so I can come back and write the value of D is 2 root 2. Okay, then the answer, yes, then the answer is negative root 2 plus 50 times 2 root 2 is 100 root 2. So the answer is 99 root 2. Yes, what's your question?
So the way that you used to solve the question where you said T51 equals A plus 50D, we can use that for any arithmetic sequence, and you get the full mark.
Yes, actually it is basically substituting into formula. You see, formula says n minus 1d. Here n is 51, so 51 minus 1 is 50. You can just write it straight. And it helps you when you are given two separate terms and you need to solve it simultaneously. So this idea is good because you can just understand the terms of an arithmetic sequence goes like A plus D, A plus 2D, A plus 3D. You know, that is how it is growing now. All right, so that's how we solve 2.2. 2.3, how many terms between 50 and 500 divided by 7? Now, to approach this question, or even the next one, maybe, let's just, let me just have an idea. What can we do? It is going to be an arithmetic sequence, first of all. Now we need to figure out what is the first term here. And then the second term, so it grows 7 by 7. The difference is 7 because they will be the multiples of 7. And then we can think about the last term. Okay, so then how is it going to happen, or what can we do? Let me just take this in another page so we can be more safer over there in terms of operations. Just that part has not quite a new page. Yes. So don't worry about the things written on the right. So now, how many terms divisible by 7 between 50 and 7? There are a few ways to approach that question, but basically, let's have the first one. So there is 49, remember, before 50, and the numbers after 50 is then, what are they? If you add 7, 56, and then plus 7, 63, and goes like that. And what could be the last one? I know there is 490, and I know there is 497. Okay, and that's all, because after 497, it is 504. So all these red ones are included. Okay. So this I can just say ignore that part. Now, and there's definitely the ones before, like there is 42 and so on. So obviously starting from 7. Now, what is the question? Question is asking how many those red numbers here? Okay, how many of them? How many numbers divisible by 7 from 50 to 500? What is a short way? Do you have any idea? We can actually find out how many numbers divisible by 7 less than 500 and how many numbers divisible by 7 less than 50, and their difference gives the answer. So that could be a kind of quicker way. So let's just let me just write that down here. For example, what we are thinking is basically let's think as a straight line. On a straight line, we can find how many numbers less than 50 divisible by 7? Okay, let me put 50 a little bit on, so that's, and till 500 now, I can find how many numbers divisible by 7 as well. So if we find how many numbers divisible by 7 in this area, in this region, starting from 7, and how many numbers less than 500 divisible by 7. So because that's kind of easier to determine how, basically like 50 over 7, 50 divided by 7 gives me a 7 point something. That means there are 7 numbers. You can count them, including 7, 14 till 49. And if you divide 500 by 7, so what do you get? You will get 71 point something. So here we have 71 numbers. So in that region, they want us how many numbers here divisible by 7. The answer is 71 minus 7, which is 64. There are 64 numbers divisible by 7. So this is one way. If you show, if you divide 50 by 7, then if you divide 500 by 7 and find their difference, that's not a bad way. So it can be solved in this approach. So n is 71 minus 7, which is 64. Now, what can be the other way? The other way is like finding how many terms in that sequence, because you can even end up such a question in that way. So that's why let me solve as a second option. So I can draw another row. So basically, if the question asks starting from 56, then 63, then 70, and then we are counting till 497. So the question is asking how many numbers. So that's the real question now. So how many number of terms is the question. So in such a question, we need to find number of terms. So if you end up such a question, how to get number of terms, then you will think with the arithmetic sequence, because you can see the differences are 7 and 7. So it's an arithmetic sequence. I know the first term. So what is my first term? If you think in an arithmetic way, T1 is 56, there is T2, there is T3, and Tn. N is the question. So which term is this? So what I know is the nth term, but I don't know the position of that term. So then we can freely use the formula for Tn. Tn is a plus n minus 1 times d. Since I know the last Tn, the nth term that I have is 497, and I know the first term, which is A156, and n is the question which we are looking for, and d is 7. So solving this equation will definitely give me the same answer. So I should get n is 64. Okay, you can get 64. You can get from the same answer in a different way. All right. So it wasn't much tricky question, but just to have different approaches, I spent some time on this now. Now 2.4. That is the geometric sequence now, and they ask the geometric sequence general term, and then it's asking is it convergent or not, and then there's this last one, solve for p if 3 to the power of p minus, okay. So let's start slowly. And what is general term? It's a geometric sequence, the question says so anyway. So we can just write the term from the formula sheet. It is a times Rn minus 1. So we need to find a. Okay, a is 2. And what is r? So what's happening every time? How do we get r? It is T2 over T1 or T3 over T2, remember? So r is 2 over 3 divided by 2. Basically, it is 1 over 3. Every time the terms gets divided by 3 and 3 and 3. So that I can write the answer just down there. Tn is 2 times 1 over 3 to the power of n minus 1. Okay, that's the answer for the first one. But the second one, is it convergent? You can happily say yes. Remember the convergence condition. Whenever r is, because we have this r between minus 1 and 1. That's the reason, because what do we get for r? R was 1 over 3. So it's in between minus 1 and 1. So any r value between minus 1 and 1 in a geometric sequence makes it convergent. So the sum approaches a fixed value. And only in that case, we can actually calculate a sum to infinity, okay? Otherwise, sum to infinity would just give an answer which is infinity. Now, the last one, it asked an equation to be solved. So let's just make this, I know A is 2 and the general term is what? We can actually find a few more terms. So I just want to have this down there, that question, and see and focus there so we can have. So that's the question you see. Now S4 is the fourth term, S infinity is the, that's actually an easy formula, remember S infinity. The formula for S infinity is A over, it's given in the formula sheet, 1 minus R. It only works when the series is converging, and this is converging, we don't have any problem. And I know A, I know R. And what about S4? That's, with the formula, it is 8 times R to the power of 3. So I can find it, or I can just write, we already know the first 3 terms. What are they? It was 2, then 2 over 3, then 2 over 9. Then you divide 1 more 3, it's 2 over 27. That's the fourth term. So this gives me, either with the formula or not, 2 over 27. Okay, now it's just substituting the values now. The right side, we have almost everything. The left side is P. So that's the question anyway. So we will find 3 to the power of what makes that condition. Let's substitute the things that we already know. So 3 to the power of P. Okay, what is A over 1 minus R, by the way? Let's find it here anyway. So A is 2 over 1 minus R. So 1 minus what was R? 1 over 3. So you can use calculator, no problem. 2 over 3. Then the calculator gives 3. So the sum to infinity of these numbers are 3. Now nothing can stop us to write the final answer. So final equation. So 3 to the power of P is equal to what? 3 minus what? 2 over 27, isn't it? That is the S4. Oh, sorry. It is not term form. It is S4. My bad. We need to find the sum, not the term for first 4 terms. So this is T4. What we wrote is T4. Yes, we got T4, but to get S4, we must add them up, add all of them. Okay, we have to add all of them, or we have to use the sum formula for a limited terms, not infinity, the other one. I prefer adding this. I mean, instead of using that formula, we can just add this, but then what do we get? And then we will subtract it from 3, Okay, let's find S4 over there. So it times by 27, so it is 54, plus times by 9, 18, plus 6, plus 2 over 27. Now it is 60, 80 over 27. Okay, so we end up, it is 80 over 27. What is this? This is S4, which is what they ask. Okay, not the third term, not the fourth term, the sum of first 4 terms. All right, now we can carry on. It is 3 minus 80 over 27. Okay, not just 2 over 27. So then what do we get here? The right side becomes 1 over 27. Now you can use log, or you can just say the 27 is 3 to the power of 3. It is 1 over 27, so it's negative 3. So you can actually get the answer without calculator, without log, and say that P must be minus 3. Okay, so that will be a nice question in that case. All right, so we have that question down here. I can put a row coming from there. So that last question, actually we solved all the way there. Now that sigma notation question, I think we can solve it in our previous page. Let's just zoom and see what's that sigma notation question. We are adding ones from 1 to k. So how many ones we are adding? You see, the idea of sigma notation is the sum of these things inside. So these things are 1. So we will be adding 1 and 1 and 1. So for n is 1, it is 1, plus for n is 2, it is another 1, another 1. So actually we will be adding 6 ones here. So that sum will be 6. So the first thing we can write, this is equal to sigma k1 to 6, what we are going to add now. So that inside becomes 6. So then what is it? That means for k is 1, we will say 6. And for k is 2, we will add another 6 and another 6. So this time we'll be adding 6 times 6s. So then the answer will be 36. Okay, because there is no affecting term in, as k. So all the terms are same. See, it is 1, 1, 1, 1, 1. Then it is 6, 6, 6, 6, 6. So because there is nothing in terms of written k here, or there is nothing here in terms of n. Okay, or there's nothing in terms of n inside the first sigma notation inside. And then when it gets to this stage, again, there's nothing with k here. It's just we are adding 6. See, if it were 6k, then what I would write, just an extension for this question. If you had, for example, something like that, k is equal to 1 to 5, 6k. You know what does it mean then? For k is 1, it is 6. Then for k is 2, it is 12. Then it is 18. Then it is 24. And finally, for k is 5, it is 30. That what will change now, because every time k is changing and what you add is going to change, but not in this question. So in this question, it is just like that. All right, I think that is so far so good. It is here. Now, next thing, we have an arithmetic sequence, find the missing values and the sum of first 24 terms and so on. Now, in an arithmetic sequence, what do? We can say T2 minus T1, T3 minus T2, or let me just solve in this way. What I know, T1 is, which is A, which is 3, and I know T3, third term. Third term is A plus 2D, and that is 11. So I just want to go from there. So that's 11. So then if I subtract the one above the one below, that means 2D must be 11 minus 3, which is 8. That means D is 4. So you can say it increased by 4. So you get 8. Sorry, you get 7. Then you increase one more, 4. So you can increase one more. So you keep increasing by 4. Somehow we can increase by 4 and 4. So that's why X is going to be 7. And then Y is 11 plus 4. Y is going to be 15. Or this question can be solved in different ways if you want. I just want you to remember that idea over there. And sum of first 24 terms, it's basically, it is Sn formula. And in Sn formula with arithmetic sequence, I must know what is A, what is D, and what is N. Now, as long as we know all these three, then we can just solve the question. A is the first term. In this case, it is 3. D is the difference. In this case, it is 4. And N is number of terms, which is already given, 24. So we will just plug into the formula and get the answer. Let me write the formula. So it's basically just substitute the values into the formula, and then you can smile. That's it. Then 2.2. 2.2 is, you see, it's like that previous question. You just need to understand here. We are adding 3 plus how many 3's are added? It is 2 from the third term. Okay, that's a bit tricky now. So you see that first one is for n is equal to 3, then for n is equal to 4, then for n is equal to 5, and then for n is equal to 2017. So we don't have n is equal to 2 and n is equal to 1. We have 2 of them missing. So that's why how many terms then we have? It is 2015. Why? It's not all the way from 1 to 2017. It is all the way from 3 to 2017. So first 2 is missing. That's why number of terms is not 2017. It is 2 less, 2015. Anyway, then the answer will be, then we can say the answer is 3 times 2015, which is 6045. Okay. Just be careful with that thinking number of terms. Now 2.3, given the quadratic pattern, I think we can skip this. We did quadratic question before. You just let me just show that you write the first differences. Yes, so it is 7 and maybe we can write it one more time in a bigger down there. So when we have the quadratic sequence, we just need to be careful in all these conditions. Let's see the differences And the second differences are important here. So the first differences are, it is 7 and then 12. And then the second difference is what? 5. Sorry, not 12. First differences is 10, 7, and then 9. So the second differences is 2. So then the next term will grow by 11, and the next term will grow by 13. So that's the odd numbers, 7, 9, 11, 13, that's it. And how do you find the equation? Remember, what do we say is basically 2a is this, equal to 2, 3a plus b is the t1, t2 minus t1, and then a plus b plus c is equal to 3. So solving 2 first, and then, a first, and then b, using a, and using a and b, you can find c, and then you got the general term and everything. Okay, just don't make any calculation error. I hope you find easy these quadratic pattern questions. This question here, determine the values of x converge. So such questions, when they ask you converge, that's a keyword, and it definitely requires the condition of general ratio, common ratio should be between -1 and 1. But then we must figure out what is common ratio on the other side. So it is T2 over T1. So you shouldn't keep writing T2 over T1 is equal to T3 over T2 is equal to T4. You don't need to write it. We just need R in terms of X. So I'm not looking any missing term. So let's just see what's happening here. Second term is 2x plus 1 square. And the first term is actually 2x plus 1, just like that. That means what? Every time we multiply any new term by 2x plus 1. That is as well as first term is 2x plus 1, and my ratio, common ratio is 2x plus 1. And you can obviously see that it is times by 2x plus 1 again and again and again. So that's what I am going to plug into the equation, into the condition for convergence. So inside R, I will write what I got from this sequence. So it must be between 2x plus 1 must be between -1 and 1. So just solve it for x then. So add both sides, increase both sides with decrease both sides with my 1. So it is -2 is 2x and 0 when you subtract 1. And finally, if you divide by 2, -1, x and 0. So any x value between -1 and 0 makes this sequence converging. Otherwise, it wouldn't converge. Okay, so that will be the condition. And determine S infinity if R is, okay, here X is -1 over 4. Does it lie in that interval which we want? Yes, you see, -1 over 4 is between -1 and 0. So that's a good condition. That's one of the conditions it works for us. And remember, S infinity is one of the easiest formula. 1 minus A is equal to 1 minus R. I mean, we just need to find A substituting X. But basically, A and R is the same thing. That will be the same R. So what is A then? A is 2x plus 1. So 2 times minus 1 over 4 plus 1. So it's going to become 1 over 2. Okay. So R is going to be 1 over 2 as well. So you have both A and R is 1 over 2. Then you can use the formula 1 over 2 over 1 minus 1 over 2. Calculator gives you a good 1 here. Okay. So that will be the answer. All right. Oh, there's a diagram. Sometimes that's you see in the questions you have a diagram. Let's just figure out the question first. It says determine the shaded area and how many squares we have drawn here. And is there a pattern or does it go to infinity? Sometimes in such questions it goes to infinity. Anyway, the diagram below is the sides of the equal length of 12. So it's 12, 12, 12. And then all those are midpoints of those distances. CB is half of AB. And then a third square is drawn. DC is half of AC and so on. So it's half and half and half. So we can say the sides are in the middle, like the whole thing was what? 12. Sorry. So yeah, one side of the big triangle is 12. Square is 12. And then the one inside is 6. And the one inside is half of it 3. So then it gets 3 over 2, and then it gets 3 over 4. So you keep dividing by 2. Okay, so that's the point. So it is 6 for the first square removed. Second square removed is 3, then 3 over 2 and 3 over 4. you are just halving your sides. And then the fourth, and this pattern continues until 10 squares are drawn. Oh yeah, we don't have infinitely many squares, we have 10 squares. So the area of the shaded part. Now, what we will do, we just need to find the areas that we removed. Basically, I can just write a condition. So area of shaded region is what? Area of square plus areas removed. Let's say that way. So how many squares removed? Areas removed of 10 squares. Sum of 10 squares, okay. So the big square area is not a problem, 12 times 12. That's 12 times 12. So how many squares removed from this one? So we will subtract, sorry. So we should subtract, so it will be minus inside. So the point, the question is now, how do we find that area, the areas of 10 squares removed? So that should give us a pattern. What is the pattern? Like the first square removed has the area 6 times 6. Second square removed has the area 3 times 3. And the third one is 3 over 2 times 3 over 2. And goes like that. So we just need to see that pattern. It should make a pattern. And most probably, yes, it's a geometric sequence. So first one removed is 6 times 6. So I can just write 36 plus. The second one is 3 times 3, which is 9. And it is 3 over 2 times 3 over 2, 9 over 4. So it carries on. And we know how many squares are there. I can write the fourth one, 9 over 16. So what does this tell us? It gives me a geometric sequence. Geometric sequence, or let's say series, because we are adding them. It's a geometric series with how many terms? With 10 terms. So we will add this. What I need to know is A as the first term, 36, and R, what's happening every time T2 over T1, 9 over 36, every time we divide by 4. And we need to know N. So what is N? 10. That's it. So we can use the formula for sum of arithmetic, sum of geometric series formula. So because it works here, what was the sum of geometric series formula? A times Rn minus 1 over R minus 1. I will use it. As long as I know what is ARN, I can find it. So let's finish our job. So from 144, I will subtract what? 36 times 1 over 4 to the power of 10 minus 1 over 1 over 4 minus 1. Okay, that is the area removed. And whatever the answer, you can smile. Like I don't have a calculator now, but you just plug in those values and get the answer for the shaded area, you see. All right, now we are getting like similar types of questions, so it is getting time to skip some of them. Quadratic sequence is given, 51st term is 50 and 51. The first differences, okay, not same now, because these are the first differences. First differences of every quadratic sequence makes an arithmetic sequence. And then 51st term is given. So how can I easily solve this question if I have given the first differences? So you see, I don't know the first term. I can say A, for example, of the arithmetic of the quadratic sequence. And the next term is A plus 3, because it is 3 more. And then if you add 7 more, it is A plus 10. And if you add 11 more, it is A plus 21. See, my quadratic sequence is something like this. So as why? Because the first difference increased by 3, then increased by 7, then increased by 11. That's why. Good, nothing is wrong. And then I know the 51st term. Okay, that's even fine. Now, how can we find maybe this from here? We can find the second differences, isn't it? So second differences in the quadratic one is 4. And using that first two, remember, using 4 and 3, I can actually have a quite nice idea. What is that nice idea? I can find what is A and what is B. Only C will be missing. And to find C, I will use my information given, extra information given. So let's do that then. What is 2A? Okay, that A is different A. Let me say this is K. First term is K. Okay, so you won't confuse with the A I am writing. So the A I am writing is for the arithmetic quadratic sequence formula. So 2A is 4, then I can tell you A is 2, and then 3A plus B is 3, and then what is B then? If A is 2, that is 6, so B must be minus 3. So you know what does this make? This actually gives me the information as Tn 2n square minus 3n plus C. I don't know C, but I know something quite nice because T51, 51st term is 5052. So I will use that information, 51st term, so T51. So since I don't know the first term, but at least I know the 51st term. So if I substitute not 1, but 51 into that formula, I can get somewhere. Yes, I will be getting, what is T51 then? T51 then, it is 2 times 51 squared minus 3 times 51 plus C. So this should be equal to 5052. So I just need to solve that equation. So when I find C, I'll get my general term. Okay, so it's just finding C from here. C is missing. And yeah, once I find C, I got my general term. That's for a 6-mark question, something nice, because first term is missing, but we could write K, K plus 3, K plus 10, whatever. That's fine. We don't, just to understand what's happening here, I wrote that. Otherwise, that's not really necessary. On the other hand, you'll just say, you'll just find the general term without C. So when you find general term without C, we can substitute with 51st term. And which term of the sequence? I'll just say you equated 20,102 and solve for n. Okay, you can solve for n. It's a happy face. Geometric sequence given there are 50 terms, write down next 2 terms in sigma notation. Okay, I just can write maybe in sigma notation condition. So in sigma notation condition, what do we write here? That's a bit different question here. I will write number of terms. So I can say n is equal to 1 to 50 because I know there are 50 terms. And inside I will write Tn, the general term. So what is Tn? The Tn formula in this case is A times Rn minus 1. So I need to find A is 2 and R is 3, 3n minus 1. So that's it now. Basically, we can just write the answers straight. So it can be A or K, whichever you like. So if I write K, I have to say 2 times 3 to the power of K minus 1. Okay. If I say N, I have to use N. If I use K, I have to use K. That's fine. So what we wrote, obviously, here is the Tn. So in front of sigma is the general term. And that is 50 terms, yes. The sum of 50 terms, we can just use formula, not a problem. And then, all right, yes, in number pattern questions, you can get proofs, either sum of arithmetic or sum of geometric. As you see, they ask here the proof of the formula, which is given in the formula sheet of an arithmetic series, the first n terms. So similarly, the sum of first n terms of a geometric series can be asked. Just go through the memorandums with the theorems books. How can these proofs be done? Okay, but as a quick and general idea, I can just write this much. For arithmetic series, what do? We write Sn, if you remember. We write Sn forward and backward. So we write Sn twice. So we can write in ascending order or in descending order. Like there is A until the last one, A plus D. And then the last one, what is the last term? A plus n minus 1D. So that is the first, that is the second, that is the last term. Now we write backward now. The last one first, n minus 1D, and then till the first one. So you write the last term till the first one. So you're basically rewriting what does the sum means, but in 2 ways. Adding from the first to the last, or adding from the last to the first. Because why? When we combine and add these both equations side by side, we end up getting 2 times Sn. And each one we are adding, what I mean is the first and the last term, the second and the second last term, and the last and the first term. Each one's what we add gives us the same thing, which is 2a plus n minus 1d. So we will be adding 2a plus n minus 1d how many times? How many terms we have? That many times. There are n times. So that's why the right side becomes n times 2a plus n minus 1d. And that gives the formula, because when you divide both sides by 2, you get what they want. So that's arithmetic sequence idea. The geometric sequence ones are, how does it work? Let me just, in a geometric series one, sorry. How does it go? Is you can write Sn again. That's not a problem. You write Sn. Okay, this time we will subtract. So I'll write Sn below. So it's, what is Sn? Number of first n terms is, first term is a, and then ar, then ar square. Remember, that will be the idea for the geometric sequence. So it goes all the way till the nth term. Nth term is, so this is the meaning of Sn. Now this time I'm not writing backward. What I am doing different is this time I'll time it by a r. All the terms I will times with r. So it is ar plus ar square plus ar cube. So what will happen now? The last term becomes arn. Now the difference comes here. We will subtract now. I'll subtract the one above from the one below. So it is r times Sn minus Sn. What is on the left side? So ar cancels, ar square. So all these cancels. What is left only is the last term of the first one above and the first one of the one below. So basically what is left is arn minus a. From then it is kind of easy actually. You just take Sn as a common factor, r minus 1, and a as a common factor, rn minus 1. So that's how you prove. You can just divide both sides, or basically you can just leave Sn alone. Okay, so that gives you this formula, and the one above gives us, what is the formula for Sn in geometric sequence? A rn minus 1 over r minus 1. Okay, so these are the two proofs we just quickly gone through over there, the geometric series or arithmetic series that you can write. Now, that is again a different question, so let me not skip 4.2. I was thinking maybe it is same, but no. This time, if whenever you are given the formula of the general term, the sum of the terms, just like in this question, what do you do? What is S1? What is S2? You will think from the basics. I think that that helps instead of memorizing anything to solve such a question. So S1 is basically T1, and S2 is what? First two terms, T1 plus T2. So this is the idea. Now, when I substitute 1 into my equation, it gives me the first term, actually. And when I substitute 2 into this equation, it gives me the sum of first two terms. So what is the T1 then? If you substitute 1 into this, it is 3 over 2 plus 4. 3 over 2 plus 4 is what? 11 over 2. You get. And what is S1 plus S2? Not just T2. Sorry, what is T1 plus T2? The first two terms. So then you substitute 2. And when you substitute 2, we get 6 plus, the first one gives me what? 2 squared, 6 plus 8. So it's 14. Now, if I know the first term and the sum of first two terms, that actually gives me the way to get the second term. What is T2? It can be S2 minus S1, which is 14 minus 11 over 2. So that will be 11, 28. So it is 17 over 2. So I know the first term. And I know the second term. We have 11 over 2. The second term is 17 over 2, and it keeps going. So can I get the eighth term? Yep. Okay. But what is another idea? Just when you understand second term is for S2 minus S1. So in the same way, as if I generalize this to find eighth term, I can say it is S8 minus S7. Because remember, what is S8? All the terms from 1 to 8. So it is T1, T2, and then plus T6, T7, T8. So that is plus T7 plus T8. So what I need is, I have to remove the first 7 of them. So when I need all these, so this part is actually S7. So while the whole thing is S8, that's the meaning. So I can even use this idea, like I can substitute 8 and then 7 and find their difference. That will be shorter. But the general idea of applying this, making use of the sum formula is you find the first term, then you find the second term, you can find difference, you can find any term you want. Okay, that wouldn't be a problem. So yeah, these two ideas can help you to solve whenever you are given the sum formula. Either find the substitute 1 and get S first term, then substitute 2, then get the sum of first two terms. So then from here you can get the second term as well. So as long as you know first and the second terms in an arithmetic sequence, you can find anything. You see, you can find anything, any term. Okay, determine the first term in the sequence that will be greater than 2011. It's kind of an inequality question. It says greater, but don't worry about it. You're just gonna find the first term. So make the Tn, we can just say Tn is more than 2007. And from then we can walk 2017, I mean. So can we write Tn? Yes. Can we get this equation solved? Yes. That would be a nice, that would be some nice actually marks over there here again. All right. So let's leave the first session from here. And later on, we will have another Zoom. Just on that time, any challenging questions or any extra questions you ask, we can answer them in our second session for number patterns. All the best, stay safe.
So